cooperate. All right, let's see what happens. Let's see. That's in 14.2. There we go. All right, let's look at number 12, for example. Oh, my bullet holes. I missed you guys. Let's see. Come in.
This is section 14, you said?
14.2, yeah. All right, so I've got the limit as my inputs approach the point 1, 0 of this. And you can very quickly, the very first thing I do if I knew, obviously, is you know I'm going to give you a problem that will actually work directly. And a lot of people just skip that and start doing paths and all this shit. I actually plug the thing in and see what the limit is, right? So, but if you plug 1, 0 in, you get 0 over 0. All right. So you verify this indeterminate already. It means I got to do something weird to figure out what it is or show that it doesn't exist. If I start to try to attack it with paths, this is why you're asking this question. What kind of path can I use? Well, the two most obvious paths would be x equal 1, exactly. All right, so normally if it's going to 0, 0, you use x equals 0, y equals 0. You approach it along the y-axis, you approach it along the x-axis. Right? So now I'm going to approach it along the line x equal 1. Right? And so if I use the path x equals 1, then I want the limit as what?
Y goes to 0.
Y goes to 0. Good. And now if x is 1, I get y minus y over y squared, which is
0 for y.
Yeah, this gets a little weird. Now this is kind of funny to watch. Don't apply the limit. This is the limit as y goes to 0 of 0 over y squared, right? Which is the limit as y goes to 0 of 0. So you get 0. So it's not indeterminate because the top is always 0. The bottom only becomes 0 when it actually gets to 0. I don't know if you guys see the distinction there between truly indeterminate and not truly. This is always 0. Everywhere along this line it's 0. The limit's going to be 0. The only place it isn't 0 is the place that it never gets to. I don't know if you guys see that distinction or not. That's one quick thing, is your simple paths are the same as they were before. It's just that they're not going to be equal 0, equal 0. They're going to be equal whatever. If it's not going to the point 0, 0. Are we cool with that? So if I try what's the other easy path to use? Y equals 0. So y equal to 0 would make this the limit as x goes to 1 of 0 over. And again, the same reasoning, this is 0. So far I haven't shown that it's different. What kind of a linear path could I use? Here's where things get a little bit weird. Now watch. You can do it. So you get started? Now, if you want to try to use mx, that's where things get a little weird. Because if it's mx, now think about it. Now, come on. Now watch. I'm not done yet, obviously, right? This is no good, because when x is 1, y would be m. Okay, that's no good. But right there, you don't have to do all the weird algebra bullshit. When x is 1, that currently says y is m. What's y supposed to be? Yeah, so you freaking minus m to make the dumb thing 0. I don't know if you guys... So right now, if x is 1, what do you mean x is 1? Because that's where it's going. Y would be m. What's y supposed to be? All right, so I'm going to subtract freaking m. So for example, the simplest line I could use, a specific line, would be x minus 1. Y equal x minus 1. Because y is equal to x minus 1n. And y is equal to 2x minus 2. And y is equal to 3x minus 3. Y is equal to 3 minus. So, now what happens when I plug this in? Now here's the interesting part. What is x going to? 1. And then y, of course, would be going to 0, like it's supposed to be. I'm replacing all my y stuff with x stuff. So this would be the limit as x goes to 1. Let's see now. X times mx minus m minus mx minus m. I'm replacing all my y stuff with mx minus m. Is that cool? But do you start to see, this is the real question is, well, how do you handle if it's not going to 0, 0? How does that affect your work like this? You just got to be careful. These two paths are always going to be easy. Here is just a straight up, this part is x is always what it's supposed to be, or y is always what it's supposed to be. Easy. The lines, and especially the freaking parabolas and whatever, they get freakier because you have to adjust it so they meet with where they're supposed to meet at the end. Maybe. Over, what again? X minus 1 squared plus mx minus m. That's squared. Yes, squared. Gross. There's one little thing you could do here. I don't know if you guys realize there's a couple little things. If you took an m out of these two, that's x minus 1 inside, right? Yeah. Right. In fact, you got x minus 1. Let me see you guys. Now it's just going to take some algebra. Let me see if you guys can see that. So I can take an mx minus m out, and then I can take an m out of that. So I get x minus 1, x minus 1. Bam, that's the top. Yes, sir.
Could you take? I was going to say it says it's mx minus m on the bottom squared.
Yeah. Keep going. And you see what I'm trying to do? X minus 1 squared is going to show up everywhere if I take what out of this?
M squared.
M squared. All the x minus 1 squares cancel, so you get m over 1 plus m squared. Don't forget my limit, which is m over 1 plus m squared. So I've shown that since it's m dependent, that means for any choice of slope, any different choice of slope, I get a different limit, which means it does not exist there. The important thing there was, how do you even build this thing, right? The path. How do you build it if the point you're going to is not 0, 0? If it's 0, 0, it's easy as shit. If it's not 0, 0, okay, you gotta, hit the brakes a bit, slow down, make sure it works for that point. You guys see that? Now here, this is algebra, which is some of our weak point. That's for sure. I've seen it, and that's too bad. This should be the easy step, right? Maybe you guys don't see it as quickly there, but still, you can work it out. Why did I do that? To try to get the x minus 1 stuff to cancel. Why would I want that to happen? Because this is a limit in terms of x. If I can make all the x shit cancel, I've got the answer. If it's not x dependent, then I don't need the limit anymore. I've got the answer. Maybe. Do you guys see what you always got to think, what's the motivation? Why would I take the step that I take? What am I trying to work towards? Yeah.
Where'd the x go from on top? X by itself.
First thing I could do is take an mx minus m out, and then I'll be left with x minus 1, right? Cool?
Yeah.
And then take an m out of that, and I got x minus 1 twice. So that's how that became that. Really? Yes?
Why is it mx minus m?
It's because I needed to go through the point xy in the point 1, 0. Right? So the simplest way to do that is to make y equal x minus 1, for example. Right? But if I have a different slope, stay with me, and I want, so let me do it like this. Y minus 0 equals m times x minus 1. Is that cool? You guys see where that came from? And then I just solve for y, bring the m through. So if it was going to the point, if it was the limit as xy goes to AB of some function, what path, what linear path would I take? So again, you can do it like we just did. A second, we can do it like we just did. I've got to go through the point xy and AB. That's neato. What's that? And let's say the slope is m. Yeah, y minus b equals n times x minus a. You guys know this stuff. You know how to build a line given 2 points, right? But now you're giving yourself the freedom of the slope being anything. So then y equals mx minus ma plus b. Ooh, gross. So now look how that matches. What was a over there? 1. So that'd be mx minus m. And what was b? 0. So mx minus m. So it's really just constructing a line using these 2 points. So that's of course why 0, 0 is easy. You don't even have to think about it. It's going to have to be y equals mx. You don't have to think about it. Which is why that seems so much harder. Let's just make it a freaking line. Okay, maybe.
What if the line only the approach of these problems?
Oh yeah, so parabolically. Oh shit. So I would recommend, let's see. So if I want a parabolic path for this situation. So if you start with just plopping down here, like if I said x squared, let's just start with y equals x squared. I'm not done with it, right? So if x is a, and I want y to be b. No. That would make it not parabolic anymore, right? You guys follow what's happening a little bit? No, okay. The simplest way, all right, now watch. So if I want to make a specific path, not n-dependent, just a specific parabolic path, I'm trying to get you guys to realize there's some shortcuts you can take. And I want this to be b now, right? So I could say, okay, so what if I did x squared would be a? So what if I divided this by a squared? So right now, what would that be at this point? 1.
Plus b?
Plus b minus 1. Do you see what I'm saying? So parabolic paths with non-zero, 0, that gets an extra step disgusting. Now what am I doing here? I'm just forcing it to work for a specific path. I really want you guys to understand. There's no process I'm using to tell you to be honest. I'm just making it work. Right? If you want a process, I could set you up a little process on work every time. Now, bullshit. Just make it work. Now you can think about what if there was an m here.
Minus m.
Now you can think about how you'd want to change this up. Mx squared.
Over a squared plus b minus m.
Yeah, well, okay, so if you do this, so far right now that's m.
Yeah.
So that's b plus b minus m. Would I memorize this shit if I were you? Hell no. I would just understand what it was that got me here. How did I construct this? How did I make this? You know, like, I don't know. I was here when it happened, and I don't know, Jeff. But, I mean, I don't know if you guys follow me. This is where you guys are not, and I don't blame you that much, because you just haven't been given the freedom to just play with shit. To really get math, you got to play with it. And you don't even associate the word play with math, which is unfortunate. You should have been associating the word play with math since math was 76 at least. When you do trig identities, you got to play with this shit. If you think back, yeah, that's what you were supposed to do, was just play around with it. So I know this ain't right. It don't do what it's supposed to do. So then I start to adjust it. Why is this okay? Because that's one path. All I'm trying to do is find several different paths. That's it. Do you guys understand? So sure, is that the only way? No, of course not. That's one. Who cares? Here's a bunch of ways. Is that the only way to do it with them? No. There's other ways to do this, but who cares? That's a bunch of paths, parabolic paths. Okay, maybe. I know some of you guys are like, why did this guy just tell me how to do it? Right? Well, that's too damn bad, right? You got to get the idea behind what's going on. What's the motivation? Where do I want to end up? I want to end up with a function that goes through this point. That's it. So if I want a linear function, I got to be careful. If I want a parabolic function, I got to be even more careful. Okay. All right. So we actually did that one all the way out, right? We found an answer. So here this would be does not exist. I like it. We got a lot of time left, so whatever you guys got. I got the answer key. Most of the answers are on there as far as I got. Yeah.
I have one more question.
Yes.
14 and 44.
Oh, yes. All right. This is the one I'm surprised. I've had a few people ask me in the office, if you have trouble with this one, good. That means you actually tried it. It's not an easy problem at all. But the funny thing is, it's not easy because it's weird to even just read through it and understand what the shit's going on. So let's go over this thing. Oh. So this is the one, let me see. I'm not going to write it all up here. Well, that's fundamentally what the function is, right? The function has only two possible outputs, 0 or 1. So that's the first thing that people mess up on, is that's the function. The function is either 0 or it's 1, depending on what the y input looks like. Oh, let's see where we go. All right. So if y is less than or equal to 0, or y is greater than or equal to x to the 4th, if y, what's it? 0 less than y less than x to the 4th. By the way, just to talk about C real quick. I don't know if you guys remember for piecewise defined functions, where are they normally discontinuous? Where would they normally possibly be discontinuous? At their transition points, right? All right. So I'm going to say about part C. You actually have to figure out why that's true, but that's the first. If I'm a student and I see a piecewise defined function talking about discontinuity, I'm going to think transition points, right, or whatever the hell you want to call them. I've actually never called them transition points before, but it makes sense. I like it. Transition, transitioning from one value to the other, dependent on the input. I like it. So part A says, oh shit. Part A says, show that as you approach 0, 0. So show that the limit as you approach 0, 0 is 0 along any path. Oh my God, Jeff, what word is that? Along y equals mx to the a, where 0 is less than a is less than 4. Okay, now, I remember I did this problem and then I checked the solutions manual and I was like, holy shit, why did they make it so complicated? Here's the thing, here's the one thing that'll get you through part A for sure, and I think it has something to do with part B. Maybe a little bit. How does y equals x, y equals x squared, y equals x cubed, how do these look? How do these look? From 0 to 1. Well, I would only care about 0 to 1 because where am I going? To 0, 0. So I really only care near my limit point. Doesn't matter what they do far away from it. So what does it look like from 0 to 1? Well, y equals x. It's a straight line. It's amazing. Y equals x squared is always less than that. Y equals x cubed is always less than that one. So here's x squared, here's x cubed. You might imagine what x to the 4th is. In fact, do you guys know what x to the 1,000th power looks like? Anybody can do that in your... no, come on. Anybody know this? It looks like this. It's insane. I don't know if you think about it. Why? Try to put it in your calculator. Y equals x to 1,000. I'll bet you it draws a big U if it doesn't freak out. Right? Think about, hey, I'm not going to get too into depth. I mean, if you do 1 half to the 1,000th power, isn't that going to be stupid small? But if you do 0.9999999999999 to the 1,000th power, it's going to be smaller than you think, but it's not going to be stupid small. So you actually end up with small as all shit, and then suddenly big. Because, of course, right at 1, it goes to 1. So it looks like it's an infinite slope there, when really it's just the resolution's too bad. Right? I don't know if you guys ever knew this. Did this never come up? So try it. Somebody try it in your graphic calculator. Have you tried it? You looking at it? What's it look like? Is it able to handle it? Oh, there you go. Yeah, so if you do it, zoom in. So he's got the standard window, so it looks like this. What really is happening is this is flat. Or, in that window it's flat. It's not really flat, but it goes from like 0.8001 to 0.8011. So to human eyes, that's going to be freaking flat. You guys with me? So zoom in a bit on that. Yeah, there you go. Do x to the 100th power should be a little less. I don't know. It's great. You guys can play with that. All right. I don't know if now that's all you need to know to do part A. To be honest, I don't know if you guys understand. You're probably not fully yet. You're like, you haven't said much yet, Jeff. But part A says, I want to go along any path where the power is less than 4. And how is that going to relate? Which one of these is it going to follow then? So remember, x to the 4th would be here, x to the 5th would be here, so there's x to the 4th. So if my power is between 0 and 4, my y values are always going to be, you can do it, so like here's x to the 4th, right? The y value for that here is going to be bigger than that. For a smaller power, it actually comes out larger from 0 to 1. We know this. 1/2 squared is 1/4. 1/2 cubed is 1/8. So a larger power ends up with a lower value. This is all you need to be able to answer the first one. Because now you know along this whole path, which one of these does it follow. So all right. Here's x to the 4th, right? Here's x to the 4th. But this guy says I want to follow any path where the power is less than 4. For example, a linear path. All the y's on this linear path, how do they relate on the y's to the 4th power? Bigger. Isn't that what that says?
It is.
Shit! So I'm following this. Along the entire path, right? Never is that not true. The only place that isn't true is at 0 where they equal each other. Do I ever get to 0? No. So then what's the limit going to be? It's going to be freaking 0 because there's 0 everywhere along that path. All right, I went too far there. Screw it. So some of you guys still won't quite be able to put that together, but I just gave you the whole answer to part A right now. So that makes me want to say even less about part B. Part B, once you know part A, part B is pretty simple. Part A, they only did one path. So part B, to show it's discontinuous there, do the other possible path. Right? That's how you show it's discontinuous, is to show that the limits, that's the easiest way to show discontinuity, is that the limits don't agree. So I love the way, despite part A, it's like, well, the whole point of this section is to try a few different paths. They've only tried one family of paths in part A. So part B is not that big of a deal. Despite all we've done in part A, it's like, you haven't done shit yet. I don't know, some of you guys understand what I'm saying? So that problem is one of the harder problems. So mostly it's just because you don't know how to interpret it. So I don't blame you that much, but it really hinges just on how these functions relate to each other. That's how I know which one I'm dealing with. All right. Enough of that one. Oh, part C, I basically, what did I say earlier? my hint was you try these guys, right? Where they transition from one to the other. Yeah. So that's my hint for part C. I did part A for you, so screw it. I'm just going to give you a hint on part C.
How about 62 on 14.6?
Oh yeah, this is gross. And you're like, yeah, I know. It just sounds weird. All right, let's see.
Understand what the first one.
That's a good first step, is to always identify what it is that you understand of the problem.
Hey, you don't know what you don't know.
That's right. Sometimes.
Sometimes.
Let's see. Oh, okay, cool. All right. So they give me a surface. You are in there, Jeff. Now, there's a whole process. It's like a more general process to find tangent planes. It's on page 994. And we went over it last time. I tried to show you how it's when z is not a function of x and y. It's when they're all intermingled. Or it's possibly, and they talk about like it's a level surface of a larger function, but it really isn't. It's just that I can't easily solve for one or the other. So there's a whole process for finding tangent planes. So this whole problem is about the tangent planes. Show that the pyramid's cut off by any tangent planes. So I got to first figure out what's the equation of a tangent plane to the surface. That's the first step of this, right? Let me see. And then how do I find the volume? So what does it mean, a pyramid in this first octant? Well, if I have a plane that meets, a plane that meets here, like this. So this is just the plane and it meets, so I'm not considering outside the first octant. Are you guys with me? And we've seen this kind of picture before. What would the area, what would the volume of this be? I don't know if you guys remember or know. The volume of a pyramid.
1/3.
Yeah. So a pyramid is basically created by, so for example, this pyramid, if I had a rectangular based pyramid, and even for me, I can do this maybe. A pyramid is just taking all the points to all the corners on the base to a single point. It doesn't matter if it's the center point. Look at that. For me, that's kick-ass. For me, that's like, hello, let's hang this shit up. For me, all right? And the volume of this pyramid is going to be 1/3 the volume of that which contains it. Right, so I cut it out of this rectangular, so it would be 1/3 LWH, right? All right, so this one was cut out from, so this is going to be like half of that, because it was cut from a triangular base. Okay, so what do I need to know? I need to know how big this triangle is here, right? And of course, this one would tell me the height of the thing. So I need to find the tangent planes to this surface. I need to follow that process. And it will be a little disgusting because you're finding all of the tangent planes. So obviously that means that your equation is going to have a lot of variables in it, right? So you're going to want to give yourself, so we have this surface, whatever it looks like. Let's pick a point like x, y, z, like x naught, y naught, z naught. Right? Are you with me? And now find all the tangent planes to the surface at that point. That's all. And then you find out, then what's the next thing? Once I know a plane, I can see where it intersects those axes. And then I can figure out what the volume is. So for example, if this intersected at A, this intersected at B, and this intersects at C, it would be 1/2 of 1/3 of blah, 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 blah. And you guys see what I'm saying? You just have to follow. So the volume of a pyramid, in general, is going to be 1/3 of the volume from which it's cut out of. So for a rectangular-based pyramid, it'd be 1/3 big ass BH. Big ass B is the area of the base. And for us, the area of the base is going to be the area of this triangle. So that's where the 1/2 kind of comes in. Are you guys? So this is actually the volume of a pyramid, a general pyramid. Big ass B is the area of the base times the height and 1/3 of that. That'll be the pyramid that you would cut out of it. I like it. Now, where are you supposed to go into this knowing that? You got freaking Google. Give me that shit. Right? Look that up. You can ask. Right? Okay. So again, I gave you the plan of attack. You follow the process for this point. Find the tangent plane to this surface at this point. And you know what about this point? This point has to be,
On the plane.
well, it's going to be, because you're going to construct it that way.
We need to find the height, right?
But it's going to be in the first quadrant.
Okay.
You with me? Okay. Once you got that, you can figure out the intercepts of that tangent plane with all those axes. And once you got that, you can figure out the volume of that shape using the formula I just gave you. Believe it or not, it's going to end up being just a number. It's going to be independent of x naught, y naught, z naught. Because don't forget, what is x naught times y naught times z naught? 1, because it has the line on that surface, right? So when you figure out the volume, you're going to get something like this. It's going to equal to 1. It's going to go away. So all the volumes of any pyramid that you could create will have the same volume. It's kind of nifty. Now, am I saying this is an easy problem? No. It's definitely not impossible. You just have to follow the process with a non-specific point. Something that I don't think you guys got enough practice with before now. I don't know. Maybe not. Maybe so. I don't know. You should have gotten a lot more problems with no numbers. Just the radiuses are, and we're just in a point x naught, y naught. You should have gotten a lot of those before now. Because there's a lot of them now. Yes, sir?
So you're not actually plugging numbers into that x naught, y naught?
No.
It's all...
That's way too specific. You want every tangent line, every tangent plane, right?
Yeah.
So you have to pick every point on that surface that's in the first octave. So there's every point on the surface in the first octave. X naught, y naught, z naught. Now construct a tangent plane for that point. So the tangent plane equation, it's not going to be anywhere near as bad as you think. You guys, please tell me, what's the process for finding, given an f of x, y, z?
X, Y.
Yeah, so it'll be fx at the point times x minus x naught, and basically repeat that, plus with y's, plus with z's, equals 0. It's the more general process to find the tangent plane from section 14.4. Yes?
Can I do number 3 on the practice test?
Oh, yeah, cool. And I'll tell you this. I'm going to be, I don't know how much I've said before about this, but remember on the quiz, I gave you, not this last quiz, but what was it? Oh, this guy, where was it? Second quiz? I can't remember. Doing a quiz with K and N and T and all this. There we go. This practice sheet you did, 13.3 practice. And I gave you up here in the corner, T of T, B of T, N of T. And I told you which ones you have to know.
Arc length.
Yeah, T of T you definitely have to know.
An arc.
And then the arc length one is easy. And the other ones I'll give you. Are you with me? Now, the same thing with the components of the acceleration. I'll actually give you that formula. You just have to be able to carry out the operations, right? So I don't know if anybody remembers what are the components of the acceleration. How do you find acceleration just straight up? The acceleration vector. Yeah, it's just R double prime, right? Is that cool? So what is it when I do the components? Well, that's going to be based on those the tangential and the normal vectors that we talked about that create that TNB frame. So I'm breaking the acceleration. I can find the acceleration vector easily. Just take the second derivative of r. Bam, I got it. Right? The second derivative position is acceleration. We know that already. But the whole idea of the components is what part is going in the direction I'm moving in and what part is going in the direction I'm turning in. That's what the components are, right? And they completely depend on which way am I going. I can't base it on x and y. I can't base it on I hat, j hat, or k hat. I can't do that. They got to be based on my reference frame for how I'm moving. So that's why they're based on t and n. So the acceleration, there's something t plus something n.
So it's curvature.
So this one is the one that makes the most sense. If I'm only talking about linear motion, it's going to be the derivative of v, right, which is my speed. Let me be very specific here. Bam. And then this piece is the piece that's a little bit weird, but it should make sense that it creates the curvature of my motion. This is the centripetal piece, right? So if I'm not curving at all, then that part should be 0. So it's got to be based on the curvature, which makes sense. And somebody pointed out that this is, you can actually get the centripetal, I can't remember if somebody said this, acceleration for this. Let me be very specific here also.
Because you said that curvature is the 1 over the radius.
Exactly, for like pure, perfectly circular motion, I get my v squared over r the way it's supposed to be for centripetal acceleration, if you happen to know that. You've taken some physics. So this is what I would give you. So now to do this, you just have to find, how do I do this for the tangential component? How do I do that? What does this tell me to do? What am I going to take the derivative of?
Speed.
The speed. So I've got to find the speed function first, and then take its derivative. So what is it? The function I'm giving you here is, which one was this again? Number 2? No, it was number 3. Let me just write like this. T, 2t, t squared. So how do I find the speed? I mean the velocity. R prime. Yeah, 1, 2, 2t. And then the speed is the length of that, right? It's like, well, the speed is the length of that. Because velocity is speed plus direction. So how do I kill the direction? I just take the length. Beautiful, make it scalar. Or, scalar function anyway.
So it's 5.
Yeah, square root of 4t squared
Plus 5.
plus 5. I like it. Let me stop there for a second. So then to get the tangential acceleration is this piece. I just have to take the derivative of this. That is the speed. I like it. Maybe. So speed is independent of direction. So that's why it makes sense that it's not a vector. So if I take its derivative, I'm going to end up with the acceleration along that direction, purely. And this part is the part that's got the curvature coming into play. So this is the part that's going to be involved in what makes me curve, my motion curve. And then I'm going to give you, of course, I give you a formula for little kappa. We've already got this. We just have to square the bad boy, which is nice. Now, let me make sure. Let me just stop for a second. So I am going to give you formulas for kappa. You guys understand? Okay. I'm not going to give you a formula for that. You just have to know how to freaking do this. I'm not going to give you a formula for that. You just got to freaking know how to do this. But I am going to give you this expression. So then when I ask you if I ask you for the tangential and normal components, you can look at that and figure out what you have to calculate. Yes, sir.
Right, so is that just kappa multiplied by speed squared?
Yes. And remember, like we said, a lot of you guys know that the centripetal acceleration is v squared over r. And kappa for a purely circular motion is 1 over r. V squared over r. And so it all comes back together. I think John pointed that out last time. I like that. right. For something that's not truly circular, for every instance, there is a circle that fits. It's sort of like the osculating circle in a way. So it's curvature for any specific t will be a value that you can interpret as the radius of the circle that would fit there. But it's changing every moment because it's not truly circular motion then. But it's still kind of the same at that instant. It's v squared over r. It's the same thing. So now you just got to throw all this stuff into the right formulas. I mean, for kappa, you can look up what you need for that. I'm going to have those formulas for you. Right. Okay, maybe. What's really, really cool, I desperately, me being the ultra geek that I am. What is the acceleration? What's the pure acceleration for this problem? It would just be 0, 0, 2. Now, what's really, really neat is if you break that up in its components, it does agree with what you find when you do these. I don't know if you can follow what I'm saying. That's a little bit more disgusting route to go, but I actually sat there and did it just because I hadn't done it in a long time. I don't know if you guys follow what I'm saying. If you can find the acceleration vector this way, and this is supposed to be breaking that vector down amongst these, right? Using these as I and j for its own specific motion. You guys with me? So that's true. This is also true. These have to be related then. Holy shit, of course they do, right? So you could do it both ways. The other way is a little bit more disgusting. You can actually... Yeah. All right. Blah, 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 blah. Oh, real quick, on problem like number 2, you don't want to, so you want to sketch whatever the curve looks like. You want to sketch that bad boy, whatever it looks like. You want to put the point you're interested in. Then you got your position vector. But then from the point, you should put your acceleration vector and all that kind of stuff, right? Don't start it off from the origin. It always should be from the point, which makes more sense. Which means if your acceleration vector was like 1, 2, then you want to count 1, 2, and then draw the vector. Maybe. You don't want to draw from here because that's not very physically explanatory, right? I wanted to come off of this point here. It would make a lot more sense for somebody to say, well, here's my velocity vector. Here's my my normal acceleration vector because it's pointing in. It would actually probably be a little more like this because it's not exactly circular motion. Maybe. I saw most of you guys doing that, but some of you guys weren't in the homework.
What about number 5?
Which one? Number 5?
Drawing.
Oh, yeah. So, for a problem like that, you don't have to make your... all right, let me say it like this. I will allow you to have your scale not be consistent for your level curves. What I mean by that is, hell yeah, I'm going to use k equal to 1. And then the next k I'm going to use...
0.
Yeah, I can use k equal to 0, k equal to negative 1, k equal to 4, because that's square rootable, right? Do you guys understand what I'm saying? Don't use k equal to 3, because that's bullshit. Then you do your length for your hyperbola, and it gets all freaky. I don't want to see that shit. I want to be able to make sure that you know it's hyperbola, you know how to construct a hyperbola, you put it in the right place. That's what I want to see. Right?
So let's use perfect squares.
Yeah, exactly. You can be smart about your choice of k. And in general, you kind of want your scale, and this should make sense, your scale to be consistent, because then the distance between curves tells you the rate of change between those curves. This should have come up in your homework, in your reading. The closer together level curves are, the faster it's climbing or falling there, the further apart. Now, my scale is inconsistent. I'm being dishonest about that, but as long as I'm labeling it, I'm telling people, hey, don't look at it like that. This is just giving you some ideas. All right, maybe. But I'm not going to, I don't care about you estimating with a square root of 3. I don't want that shit. Right? I want, So for this one, let's see, where'd you go? Here we go. Now what happens? So then, level curves. What's the main? What are they going to look like? So these aren't traces. Traces are like you could do a trace in one plane, a trace in another plane, a trace in another plane. Now we're sort of considering the XY plane to be our input. So we don't have traces in all these different planes. You could do that, but we don't look at that way as much anymore. Now we say level curves, which involves making the height k, right? So this would be k equal x squared minus y squared. So if k is 0, what happens? This is where people mess up a lot. If k is 0, what happens? Careful. Y equals plus or minus x. You guys see that? Because you get x squared equals y squared. Square root means plus or minus. Y equals plus or minus x. So for k equals 0, you get basically that. Hopefully you draw it better. All right, so then I would put like a little 0 and a little 0. If k equals 1, tell me some features of that. What is it? I already said it earlier. It's hyperbola because it's a minus, right? If it was an ellipse, it would be a plus. In fact, in that case, it would be a circle, right? Which is a special ellipse. It's going to sit on what axis? The axis that's allowed to have intercepts. The x-axis, right? You try to find the y-intercepts, you have negative y squared equals 1. That's not real, and we're not dealing with unreal things, thank God. Can you imagine this class including complex possibilities? All right, stop doing that. Right. So we always deal with real stuff for the moment, right? So that would just be a hyperbola sitting on the x-axis, right? Oh, so it opens left and right, is what we're saying. Is that cool? When I say sits on the x-axis, I mean it actually touches the x-axis. So that would be, and it actually will live in here. I don't know if you guys realize these would be the asymptotes for that. Because it'd be 1, 1, 1, 1, 1, 1, 1, 1, make your little thing, majig. It's going to live inside there. You guys with me? Wee, wee. You make whatever sound effects. What if k equals negative 1? What happens? Is that okay to leave it like that? Is that standard form? You got to divide by negative so you make it a standard form. So of course that makes it become a hyperbola that sits on the y-axis the same way as I just did. Yeah, exactly. Cool. All right, so it would be here. So this would be 1, 1. This would be negative 1. And then if I said, like, do 4 or 5 level curves, then I would use k equal to 4 or negative 4. The next reasonable choice for me to draw this by hand. I like it. But to be honest, that would be plenty enough to establish a pattern. The negatives seem to be going this way. So do you understand when I look at this, that means that this is below the xy plane. These are above the xy plane. Right?
I got a question, I'm not sure if it's the right question. So if you're trying to, like, f of x at any point in there, how would you find that? F of x, f of y?
Oh, you mean f of xy?
Yeah. Okay.
So, like if I put a point right here,
Yeah.
and I want to know what the height is of this,
Oh.
the best I can say is it's between 0 and negative 1.
Oh.
Right? I mean, this isn't enough to give me resolution like that, but at least I know, is it below the xy plane? Yeah. To be above the xy plane, it's got to be on this side. But now it's between 0 and positive 1. Does that make sense? The resolution on this is nowhere near enough to figure out what the actual value is, right? But I can figure out general stuff like that. I like it. I like it. Oh yeah, you'll love number 6 because it's actually part of your homework, and I put it on the answer sheet.
Yes, it is. You're right.
Yeah.
Sorry, I got discussed by who?
What? So You're welcome. So part of your homework will be done. Hopefully you do things correctly, not even look at the answer key until you've tried it actually yourself. But I know if you guys are just going to copy the shit down and give it to me, it's fine. It's going to happen. Oh well. Because a lot of you guys do that kind of thing already anyway. So this is just going to make it easier for you. Not everybody. But enough of you do that it makes me a little pissed off. And I'm sure I've made that clear. But hey, if you want to continue going down a path where you don't understand anything, you're doing a good job if you're doing that for yourself. That's really, 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 really stupid. But for the rest of you actually honestly doing this stuff, and yes, it's hard. Shit, yeah, it's hard. But that's the point of homework. The point of homework is not to get it all right. That is not the point of homework. The point of homework is not a scavenger hunt, go find the answers wherever you can. The point of homework is to get you used to the concepts. What do I use here? What makes sense? I tried this concept that didn't work at all. Why wouldn't it work here? You've got to go through that. And less students are doing that nowadays. And it just makes me cry. Right? Anyway. So I'm going to keep on requiring people to do that, though, because that's the right thing to do. And more students will hate me. And oh well, I don't give a shit. Right? All right, enough of that. What about... Yeah.
4B.
Yeah, okay, good. That was another one. So this by itself,
So the domain should be between -1 and 1.
Should be between -1 and 1.
yes, because the inputs of the inverse sign should follow the outputs of the sign. And the outputs of sign go between -1 and 1. I like it. So therefore, anything that's inside here has to be between -1 and 1. So for 4B, then what do you write? What do you set up?
-1 is
From
less than-
-1 to 6 plus 1.
Yeah, say x plus 2y has to be between
-1 and 1.
-1 and 1. Now, to make this a little easier, I would kind of break this up into two parts. They become two lines, and you want to shade.
Left side.
Oh, okay. All right.
Well,
So this will be. So it doesn't. You don't have to. You could actually just do this: x minus 1 over 2 less than or equal to y less than or equal to. Where'd I go? Negative x minus 1. 1 minus x over 2. Cool.
so it should be between.
So y has got to be between those two lines. So you graph this line, you graph that line, you shade between them.
It's a part of the homework. Does part of the homework anything?
Yeah, I know. It sounded familiar. I think I stole it from the homework again.
My question is, will you put something similar to 48, 14.4